Right, huh?
Now, what I will do, let me explain what this polynomial will How's the scene in Germany? Are you still under lockdown?
So actually, so formally, it's actually still in quarantine. I mean, mainly, I mean, now is winter, all that stuff, but now it's still quarantine. So like almost till mid of Jan, it will be proper strict quarantine.
Lockdown, you mean?
Huh, huh.
But it became bad suddenly. Eh?
Huh, huh. Like just in December, like from the mid of December, it became pretty bad.
Okay, now see what is now see. You have seen. Uh, yeah. Now see, you have
Mm-hmm.
seen area of under a curve, right? If
Mm-hmm.
I give you a curve like this, whatever. But in these two
Uh-huh.
points, if I say x equal to a, x equal to b, this is f of x, y equal to f of x.
Mm-hmm.
So this area, this area A, area of shaded region is equal to integral. What's the answer? Integral what? F of x dx
Uh-huh.
x equal to a to x equal to b.
Oh
Correct?
yeah, right.
We have
Uh-huh.
done this.
Okay.
Now
Uh-huh.
see,
Correct, correct.
Neil, I want to finish off 2, 3, and 4 and
Mm-hmm.
in January. At least 2 and 3 in January. So that,
Mm-hmm.
1 second. Sorry. So that in January, when I give you the test, I'll give you paper 1, paper 2, I'll give you 2 papers.
Okay, okay.
This time, tomorrow, it's only 1 paper,
Mm-hmm.
50 mark test.
Done, done. Okay,
January, I'll
sir.
give you 2 papers, each of, 110 marks. Of, I'll tell you.
Okay.
I want to finish 2 and 3 next month, and 4 and 1 will remain for February. 1 is very basic.
Fair enough.
We'll first do 4.
Okay, sir. Fair enough. Okay.
Okay, let's go this way. Gotcha. So area of shaded region is so much. Okay. Now suppose if I was to revolve this, this had to revolve. Okay. Let's say I have a curve here. Let's say the same curve.
Mm-hmm.
Okay. Now if this much, area was to revolve around the x-axis,
Mm-hmm.
it looks like G. No?
Mm-hmm.
Okay, I'll do like that.
Okay.
If it will revolve around the x-axis, okay. So
Mm-hmm.
it will go like this. Right. No? So what will I
Mm-hmm.
get? I'll get a solid. I'll get a solid. It will be something like this.
Mm-hmm.
Okay?
Right. Mm-hmm.
Get a solid like this. Correct?
Right, sir. Uh-huh.
Something like this. Okay. I mean, you can't. Okay, you're not allowed to laugh. Okay, at my lack of artistic skill.
Huh. Oh.
This is my x-axis. Okay?
Right, sir.
So I get a solid, which is like this.
Mm-hmm.
Correct?
Right, right, huh?
This uh, this is whatever is the radius. Okay,
Mm-hmm.
and here it is this. Okay, no? Now this volume of revolution, this is called volume of solid obtained obtained by revolution of y equal
Right.
to f of x, when this revolves around the x-axis, around the x-axis between x equal to a and x equal to b. Okay. Okay. Now this
Right.
was solid I have obtained. I obtained this solid by revolving y equal to f of x around the x-axis. This is the x-axis between x equal to a and x equal to b. Now this volume v is equal to pi times integral y square dx between x equal to a and x equal to b. Okay. Now this formula is given in your formula booklet. Correct?
Okay. Mm-hmm.
Have you understood?
So
Now see,
this is basically the volume of the, I mean,
the solid obtained.
solid, yeah, huh.
When
So,
you
okay.
rotate a line or a plot,
Mm-hmm.
you get a three-dimensional figure.
Okay, okay,
Okay.
okay, okay.
See, area is two-dimensional.
Then,
It's a plane. Okay. This
mm-hmm.
is volume. Now let me give you an example. Suppose um, x-axis, y-axis. Uh, suppose this is my line. I have a line. Okay.
Mm-hmm.
This is x equal to 0, right?
Mm-hmm.
X equal to suppose h,
Uh-huh.
and this point B, point A. Now this the coordinates of A are 0 and R.
Okay.
Hmm. Okay, 0 and R.
Mm-hmm.
The coordinates are 0 and R.
Uh-huh.
Um, now what is the equation of the line? Can you write the equation?
So equation of line is y minus y1
Okay.
equals to m x minus x1.
Okay. So
So in this case, it will be y minus 0. No, 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 no. Y minus r, I think, yes.
okay, y minus R
What? Okay, y
equal
minus
to
r equals to m. M will be, I'll tell you, so m is y2 minus y1. So 0 minus r by by h minus 0. So that is minus r by h. Minus r by h multiplied by x minus x1. And your x is x, and your x1 is again 0.
so what's your answer then?
Okay. I am not writing actually, so but I'll write it once.
Okay. See, what is the
Y
gradient of the
minus.
line?
So gradient here is 0 minus r by h minus 0,
So
which
minus
is
R
minus
upon
r
H.
by h.
Okay.
And so here the equation will be y minus y1. So let's take r equals to minus r by h multiplied by uh, x minus x1. Let's take r. Okay. x1 0 x minus
Is
zero.
it this? Do you get this?
I 1 second. So I'm just telling you. Rx. Huh? I get that. So right? Huh? I get that.
Okay. No, I think this is complicated. Huh? चलो कोई बात नहीं. It's okay. Never mind. Let it be complicated.
Okay.
Very complicated. So now when I rotate this, what will I obtain if I
Volume.
rotate? What do I get?
I mean you get a cone.
You get a cone. Very good. You get a cone.
Mm-hmm.
So now my cone is this. I want to find the volume of the cone.
Okay.
I get a cone. Okay. I'll find
Huh.
the volume of the cone. Now my formula says that volume of
One
cone.
third pi square h.
No, that is a different thing. Now let us see what we get using calculus. My formula says volume is pi times integral y square dx.
Ah,
Correct?
integral. Huh.
And now,
Correct.
now,
Correct.
now,
Huh.
now what are my values of x? X equal to a to x equal to b. What is a?
My a is 0
Zero. Very good.
and b is h.
Perfect. Okay.
Mm-hmm.
Okay. There's no volume. A equal to h 0 to h y square dx.
Mm-hmm. Right.
Okay. Now what is y square? Okay. Now see y is so much. Okay. What is y square?
Mm-hmm. Y square is. I mean, which one do we take as y 0 or the
No, no.
first
The y
one?
is so much. No? So y square is minus
Oh. Okay. So minus r x by h plus r whole square.
which is
Mm-hmm. That will be equal to a square plus 2 into this into this. So 2 into hx. Sir. Plus. So answer, sir, r square x square by h square minus 2 r square x by h plus r square.
perfect.
Mm-hmm.
Very good. So my volume will be pi times integral r square. Okay.
Mm-hmm.
Minus 2 r square upon h x plus r square to dx, right?
Uh-huh.
X takes values from 0 to r, 0 to h,
Correct.
right? No, I will just open the bracket. I will split it, and that's
Okay.
equal to pi times integral 0 to h r square upon h square x square dx
Mm-hmm.
minus again pi 2 r square upon h x dx
Mm-hmm.
again 0 to h plus pi times r square dx. Is this correct?
Uh, yep.
It's correct. No?
Yep.
Now see, remember
It's correct.
R is constant, H is constant. Okay, R and H are not
Mm-hmm.
variables,
Correct, huh?
so I can take them out. That is pi R square upon H square integral x square dx 0 to h
Uh-huh.
plus pi into 2r square upon h integral x dx
Mm-hmm.
0 to h
Mm-hmm.
plus uh, pi
Pi r square integral h 0 h.
because r
Mm-hmm.
and h are constant. No? Okay.
Right, right.
Now
Uh-huh.
what is integral x square?
Integral x square is x to the power 3 by 3.
Between 0 to h. Okay.
Hmm.
How much is this integral? 2 pi r square upon h integral x dx.
Integral x dx is again it's same x square by 2.
0 to h. Okay.
Hmm.
Plus pi r square. Now what is integral x? Integral dx?
uh, Integral dx was I not sure. One second.
X.
Integral dx will be
Is x. Huh?
x. Okay, huh?
Correct. Huh? See, you look at this, okay? Integral dx,
Mm-hmm.
is, okay, I'll show you. Integral dx
Mm-hmm.
is integral x raised to 0 dx.
Mm-hmm.
It is x raised to 0 plus 1 upon 0 plus 1, which is x upon 1 is
Mm-hmm.
x. Okay?
Mm-hmm.
Have you understood?
Yes, sir. Yes, sir.
Okay? Now let us see
Mm-hmm.
now. Now this becomes the x cube, now when this will be what? Pi r square upon x square into h cube upon 3
Mm-hmm.
minus 0 cube upon 3, right?
Minus 0 upon 3. Yep.
Correct, na? H cube upon 3 minus 0
Mm-hmm.
cube upon 3, which is 0. I'm not writing it. Is that okay?
Okay.
H
Mm-hmm.
cube upon 3 minus,
Which is 0. Uh-huh.
okay. Now 2 pi r square upon h. This becomes h square upon 2 minus 0 square upon 2
Yeah.
plus pi r square. This becomes h
To the
minus
power.
0. Is that correct?
Huh, huh, huh. Yep.
No. That will be pi r square upon h square into h cube upon 3. Correct?
Mm-hmm.
Plus 2 pi r square upon h into h square upon 2. Yeah?
Mm-hmm.
Plus pi r square h. Right?
Right, huh?
Okay, now see. This h square will cancel. This
Mm-hmm.
h will cancel. These two will also cancel.
Right.
I have 1 upon 3 pi r square h. Okay? Plus pi r square h plus, I think I made a mistake somewhere. They should be minus, huh? It's
Why?
minus, minus. Okay,
Right, right.
this is minus. It's minus, correct. Here I wrote plus.
Mm-hmm.
So it's minus, 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 minus. This will cancel.
Mm-hmm.
So I have all my volume of cone is 1 upon 3 pi r square h. Now, which is the formula you studied in lower grades? Huh? Volume of a
Right,
cone is so much. Is that right?
Mm-hmm. Mm-hmm.
So have you understood volume of revolution?
Yes, sir, absolutely.
Absolutely. We'll solve one question here.
So actually, the basic I've understood, but I have to practice, obviously, like
Ah,
on this concept.
okay. This you'll have to practice. Huh? Okay, let us
Mm-hmm.
see. We'll do this one. Chalo. We'll do this one. Um, question number 6.
Okay, okay,
Okay. Okay, this one. Okay. Now see, we are given this diagram. Okay. The function is defined
mm-hmm.
as under root r square minus x square. Now state the geometrical shape of the solid of revolution obtained by rotating f of x around the x-axis by 2 pi radians. Now, what do you understand by 2 pi radians?
Um,
It means 360 degrees, correct? Okay.
2 pi radians into
See,
we have to convert, so radians and degrees is into 180 by pi. Acha,
yes.
okay, right. So 360 degrees, yep.
Pi radians equal to 180 degrees.
Hmm.
So 2 pi radians, 360
Is
degrees.
180 by pi into 2 pi.
Okay. This means when you revolve
Hmm.
this, okay, I've got this plot. So when I revolve this by
Hmm.
2 pi radians, what do I get? I'll get I'll get
Acha, you're
a
asking me,
hemisphere.
okay, so well, we get hemisphere, correct?
Hemisphere. Correct? Huh?
Hmm. Hmm.
Is that correct?
Yes, sir, yes, sir.
You've understood?
So you can hear me now?
Yeah. Yeah. Okay.
Okay,
Now
okay.
write down an integral that represents the volume of this solid. Okay. Now
Uh-huh.
this is the hemisphere. It's a hemisphere. Now you have to write down or see. So you're rotating this between x equal to 0 and x equal to r. Yeah,
Yeah.
correct, no? Okay.
Mm-hmm.
This is 0 and r. This is r and 0, obviously.
Zero.
Now, what is the equation of the curve? Y equal to r square minus x square.
Uh-huh.
Y equal to root of r square minus x. Okay. So what is my formula? Volume of revolution is what?
So do it this time. Next time I'll do 100%.
The volume of revolution V is pi times integral y square dx. Okay.
Nice with you.
Between x equal to 0 to x equal to r. Right?
Huh?
Now what is y
Right, right.
square? Now see, my y is root of r square minus x square. This implies
Mm-hmm. So equal to r square minus x square whole
brilliant.
square is
So this will be pi times integral r square minus x square dx between x equal to 0, x equal to
and
r.
r.
Okay, now this is quite simple actually. That's equal to pi times integral 0 to r square dx minus pi times integral x square dx 0 to r. Correct? Now
Correct, correct.
r is constant, huh? Isn't it?
Right. So outside
So it will be pi
r square
r square integral
and dx is
dx
again x
0 to r, 0
0
to
to
r,
r.
and minus pi. Now integral x square, right?
Integral x square,
That is
right?
our x cube upon 3,
Right, correct. X cube upon 3. Yep.
0 to r.
To r.
Now
Yep.
integral dx is
Dx.
how much?
So last thing we said x. So x.
X between 0 to r.
R.
And this is 1 upon 3 pi x cube,
Pi
pi
x
r
cube.
cube, pi r cube. Correct, no? You'll put x equal to r, no?
Acha, right. Okay.
That's equal to, I'll put x equal to r. So pi r cube minus 1 upon 3 pi r cube. That's equal to 2 pi upon 3 r cube.
Mm-hmm.
That is volume of hemisphere.
Acha, okay.
Okay, that's volume of hemisphere. This is 2 pi upon 3
Okay. Okay.
r cube. Therefore, volume of sphere will be what?
So,
4 pi upon
so,
3,
so, so
5.
when they say, so when they say write down the integral, so basically this full thing is your answer. Write down
Yeah.
integral that represents
No, the answer is yeah, okay, yes, yes. They see the integral is this,
only the first
this much, okay.
two.
Now you want
Huh.
to solve part C, no? You have to solve the
Acha,
integral.
show.
So that's volume of the hemisphere. So
Mm-hmm.
volume of sphere will be 2 times of this, no? Because
Right, right,
one sphere is made up of 2 hemispheres, right?
right,
So volume of sphere is 2 pi upon 3. That's equal to, okay?
Mm-hmm.
We done this? Understood?
Yes, sir.
A, B, C we have done. Okay. Now I think we will start with, just look at it. Now we will start with the differential equations. Huh?
Okay, okay, sir.
Okay, because we have to, uh,
It's not that tough, honestly. So
Correct?
these sort of sums.
Come
So I
again?
say this is not very tough.
It is not tough at all.
Hmm.
Really see, but you have to submit your work, my friend. No? I have to check your work.
अरे
If you don't
हाँ सर.
submit your work, how will I check your work? Can I check your work without you submitting? See, you should submit your work. Now again, this, no, I'll give you. See, just bear with me for this unit, okay? Next unit onwards,
हाँ
we'll
सर.
have a workbook ready. From
Okay sir,
unit from
100%.
unit
Okay.
two onwards, we'll have a ready workbook with questions,
Done sir.
classwork, homework, everything.
Done sir. Done sir.
Okay. So I'll give you a worksheet on this. I'll give it to you tomorrow itself.
Okay sir.
Okay. Now, I think we'll do chapter review only. We'll do. Should I take questions from here or questions from there?
So from there as in, so take from here only, no?
Those are
Because the other book
exam
I have, I can
questions.
practice from there.
ठीक है, we'll do this. चलो कोई बात नहीं.
Okay.
Okay. Okay. Differential equations.
So is this like different from differential calculus?
No, a
Like,
differential equation is an equation. See, like if you see this, no? See, normally we know y equal to mx plus c or x plus
uh-huh.
2y equal to something. See, these are equations.
Mm-hmm.
Now, differential equation is an
Okay.
equation in which you have derivatives. Like if the dt
Okay,
upon
okay.
this is a differential equation. You know, if
Acha,
if
acha,
I if
okay.
I say if I say okay uh, if I say y equal to k into t minus t naught. Okay.
Mm-hmm.
Now this is just an equation. If I say dy by dt equal
Mm-hmm.
to k into t minus t naught. Now it's a differential equation. I've got a derivative. Huh?
Mm-hmm.
Okay. So if there are derivatives in an equation, then that equation becomes a
Differential equation.
differential equation.
Okay,
Okay.
okay.
So now, okay, I'll solve these questions first. Question number 5, and then, mhm. Okay, I think I'll solve two. Okay, we need to solve. Solve question number 5, then we will do question 7 and 10. Then we will do Euler's method. I think that should be
Okay,
enough for the
okay.
day.
Okay, sir, done.
Uh, okay,
Mm-hmm.
just give me 1 minute. Huh?
Okay, okay.
Okay. I will take less than 1 minute, in fact.
Ah, sir, no problem, no problem.
Ah, I think I'll have to
Yep.
make it bigger. No, this is better.
Uh,
because otherwise this x plus y was not
acha, acha, okay, sir.
okay. Now dy by dx is equal to e to the power x plus y.
Mm-hmm.
So dy by dx e to the x plus y. Okay.
Mm-hmm.
So what I can do is e to the x plus y is equal to how much? That's equal to
E to the power x plus y. So, derivative, no? Acha, okay. So that will be equal to same, I think. So it will be low.
okay. Yeah.
So this will be chain rule, no? This thing.
Mm. I don't want to. I have got
Acha,
the derivative.
fair
No,
enough.
no. See, I want to
Okay,
find
e to the power x into e to the power.
one second. One second. I want to find what is y. I want to find the function.
Oh,
I know the
oh,
derivative.
yeah, yeah, yeah.
Okay.
Right,
So
right.
dy by dx is known to me.
Okay.
So what I'll say okay, dy. I will separate. I will
Mm-hmm.
separate the variables.
Okay.
Separate the variables.
Okay, sir.
Okay. So what I do is
Mm-hmm.
I will say dy upon e to the y is equal to e raised to x px. Correct? I got e to the y
Mm-hmm.
down. I took this dx on the other side.
Mm-hmm.
Okay? I will say integral dy upon e to the y is equal to e to the x integral e to the x dx. Yeah.
Okay.
Now what is the integral
Mm-hmm.
dy? What is the integral upon ey dy?
Integral of d. Instead of
Integral
only
dy
dy.
upon e to the y is what? You see the formula booklet.
Okay, so open it 1 second. Integral of dy upon e to the power y. Okay. So just 1 second. Uh, so it is minus 1 by e to the power y plus c.
See, we can leave it one. Minus 1. What is this?
So of e to the power y integral is same e to the power y
What's the answer? What
plus
is
c.
left hand side is what?
So
Minus
left
1.
hand side, is minus one
Huh?
upon so one minus one upon e to the power y plus c.
Okay, let's see. We can put 1 only. Is
Okay.
equal to e to the x. Okay, and we'll put plus c here.
Mhm.
Okay, that's my equation.
Okay.
Okay, minus 1. Now we can, of course, write it as you want. Okay, e to the x plus 1 upon e to the y plus c equal to 0. Whatever. Huh? That's
Mm-hmm.
my
Mm-hmm.
equation. Okay, that's my answer.
Mm-hmm.
Oh, no, no.
Right. So,
That's not my answer. I'm so sorry, my dear friend. No, 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 no. That's not the answer. I have to find y.
right. Huh.
I have to find y. So what I will do now? Mm, Okay. Uh, okay. I will take logs on both sides. I will take ln because I got e, no? Then
Okay.
ln. So
Mm-hmm.
ln this is equal to ln of this whole thing. Okay. I'm taking logs on
Okay.
both sides. Ln. Now what is now? See, this is ln of minus one minus ln
By e to the power ln minus 1. Okay, huh. Okay.
now. Uh, what will this be? What is the ln of
So
minus one?
so how do you know you have to take ln?
I want y. No? I don't want this.
But how do you know ln exactly?
So if it is log, no, see, I'll tell you why. I can take log also. Log e to the power. That would help me. But if I say ln,
Mm-hmm.
ln e to the y is y.
Okay. How? Okay.
Okay. I think
Okay.
I think I will write it better. Hey Baba, eraser is here. You'll have to write it better. You're right. What you did is correct. Okay. Nothing wrong.
Okay.
You said minus one upon e to the y, right? So I will say
Mm-hmm.
okay. Minus one. This is what you said, right?
Right.
Now, which means e minus one equal to, if I take logs on both sides, see if I say, if I take log on both sides, yeah, okay.
Mm-hmm.
So what is ln one?
1.
No, zero, no.
So actually, I'm not very sure about logs.
Ln one is zero. You can check in your
Achha.
calculator.
Okay, so just one second. ln 1. Yep, 0.
Zero.
Mm-hmm.
Ln minus one is showing error.
ln minus 1.
Not we
Same,
can
huh?
we cannot do this. What we will say is 1 upon y, 1 upon e to the y is equal to minus e to the x minus c or plus c. That c does not matter. Okay?
Right.
Are you getting it?
Yes, sir.
Now, now when I take ln on both sides, what do I get? Ln 1 upon e to the y to ln c minus e to the x.
Mm-hmm.
Correct, no? That's to be
Mm-hmm.
this. So ln of this is 1 upon y is ln 1 minus ln e to the y. Okay, that's equal to ln ln1 is 0.
Mm-hmm.
So minus y is equal to ln c1 is e to the x. Y is equal to minus ln. Understand? Ah,
Yo.
correct?
Mm-hmm.
You're not clear with logarithms. Huh?
Actually, no, sir. With logarithms, not so much.
Okay, we'll do logarithms when you're doing
Yes, sir. Of
unit
course.
one, no? We'll do logarithms.
Huh,
Don't
sir.
bother. Okay, let's do this one. dy by dx
Okay.
by dx
So
is
basically, in like all these sums, you have to basically solve for y.
exactly by
Sir,
dx.
sir, sir. So can you just take a screenshot of this full page and send it to me for
Of course,
homework on exam test?
of course. I will all this
Ah,
for you only. I'll give it to you.
ah.
Okay, of course I'll give it to you. Why not? Huh? Okay. Um, here this one. dy by dx is y plus y cos x upon y square plus 1. Okay. So at this space here, I think I can do it here. dy by dx by yeah.
Mm-hmm.
Okay. Uh, so I will say this is equal to y to 1 plus okay, dy by dx.
Mm-hmm.
Now can
Mm-hmm.
I? How will I separate the variables now? I want x and y to be separated. What will I do now?
So they already are separate, no?
Yes. So what will be the next step? Maybe you're right. They're separated. What will I do?
So next step, you will just
I will take this thing.
attach one and put the other one on the other side.
I will say y square plus 1 upon y
Plus one by okay, huh?
is equal to 1 plus cos x
Dx.
integrate. No?
So in every sum, sir, we'll do integral
Yes. Yes.
after we have separated the y and the x.
Yeah. Okay.
Okay.
Okay. No. No. Can you tell me the integral, please?
Just one second, sir. Do integral after separating. Huh. Integral of this, no? Y square plus 1 by y. So the first one will be, sir, y square by 2
Okay.
plus ln y
Okay.
plus c. I mean, that's it,
See,
ln
see,
y.
put C at the end. All the C's. So
Hmm.
you're right. Uh, y square upon 2 plus ln y square.
So for ln y, it is in modulus.
Okay.
Hmm. That's it. And next one I'm solving. So just one sec. One plus cos x. No. So this one is x plus sin x.
Correct.
So integral one is x. No.
Yes.
So x plus sin x.
Okay, we'll do some interesting problems. These problems are not so okay. Okay, Joe, let's do this one again.
Okay. Okay.
I'm sorry, I'm yawning.
I don't know. So it's fine.
This is the last question, and then we'll do Euler's method.
Okay.
And I think we are done with this unit, except area of trapezium. No, except trapezoidal.
Okay.
Okay, then we are done with it. I think this is we'll check.
Okay.
But I'm happy with the work. Eh? We managed to finish. When did we start?
When did we start? Oh, I don't remember. So long back.
Mid-December. No?
Maybe.
Happy. So, next month in January, we will finish units 2 and 3.
Sir. Done.
We'll do that. Okay? And
Okay.
4 will
Okay.
remain 4 is statistics. We've done chi-square test already. So
Mm-hmm.
chi-square test and that unit 1 kana that matrices and complex everything else is 2 bases.
Okay, sir.
You can do that. Right? Matrices. No. There's matrices, complex numbers, amortization, annuity. Do you know amortization annuity?
So I know what?
Do you know amortization and annuity?
What? No.
That's very simple. You have
Okay.
a
Okay.
GDC. It is,
Okay. So anyway.
I think
Anyways. Okay.
hopefully let's try to keep a target date of
Uh-huh.
for finishing the complete thing. Let's keep a target date of mid-Feb. We'll try
Mm-hmm.
for
Okay.
mid-Feb so that then imagine we get 2 months. Just or at least if not mid-Feb, at least end Feb.
Mm-hmm.
So that we get 2 full months. For revision and paper solving.
Fair enough. So anyway.
Paper, especially paper 3. Actually, they should scrap paper 3, I think, because of COVID. Because,
Right.
in other subjects, they have curtailed the portion,
Okay.
but mathematics, they have not.
They have not. So
It's
anyway.
not fair. No, IB is not fair.
Maybe.
IB is dark. It's Indian. It's not dark. Yeah, good. Okay. Read this question. Okay.
Newton's law of cooling states that the rate of change of temperature dt by dt, temperature by time of an object is proportional to of an object is proportional to the difference between its own temperature T of t and the ambient temperature Ta, that is temperature of surroundings. Okay, that is dt by dt equals to minus k T minus Ta. Suppose you have just poured a cup of coffee with temperature of 75 degrees Celsius in a room where the temperature is 24 degrees. Okay. Okay. So
Okay.
basically, in place of T, we have to put 75, and in place of TA, you have to put 24.
But you have to, what do you have to do?
First, I think normal differentiation.
No, no, you're given that. Okay. dt by dt
Acha,
is given to you.
huh.
You want to find temperature. What is T? Okay, you want to find
So
the
they see,
temperature function.
so, right, right.
Okay. What is the temperature function? Because what is given to you is, what is
So, so,
given,
so, so, so then here, do we just separate the like dt? I mean the time from the temperature part.
exactly. See, because see,
Okay.
what I don't know what is the temperature. I know dt by dt.
Mm-hmm.
Let's not use data, I know dt by. So just find the temperature function.
So find the temperature.
T.
So I don't. How do I find temperature?
Oh, you're given the differential. You're given the differential equation. dt by dt is,
So after the integral then.
yeah, okay.
So isn't the temperature just 75 degrees? Because it's given over there. Suppose you have just poured a cup of coffee with temperature
See,
75
one
degrees.
second. See, I tell you, temperature is changing with time.
Uh-huh.
At a particular time, at a particular instant, the temperature is 75 degrees Celsius. Now the room temperature is 24. Room temperature will not change. So it will change over a longer period.
Okay,
It will
okay.
not change every second. But the
So I guess then to find temperature, you have to do like separate like the time from the temperature part and then do integral, like the last sum.
yeah, so how will you do it then?
So basically what I think is just keep the 1 by dt on one side and put the minus k t minus ta by dt on the other side.
You can put dt upon t
Huh.
minus k.
Okay, huh. Same. Okay, minus k into dt. Huh.
Now we do integration.
Okay.
N minus dt, right?
Huh.
Correct. Huh?
Yup. Okay.
Because ta is constant. Huh?
Mm-hmm.
Equal
Okay.
to minus kt.
X t minus t. Okay.
C.
Huh. Right. Okay. Acha. Okay.
So t minus t is equal to the power minus k. That's c. That's equal to e to the power to the c. Yeah?
Mm-hmm.
What will this be? Actually, e to the c is some c is a constant. So e to the c is also a constant. Suppose we use
Mm-hmm.
what lambda. So t
Okay. Uh-huh.
e. Yeah?
Sir, how are we getting this part t minus t equals to e to the power minus kt plus c?
Analysis. No, see when if I see, I think what is logarithm. If I say a raised to n is equal to b,
Mm-hmm.
what is my base?
So are these like logarithm rules at the part over there?
Yeah.
Acha, okay.
No.
So
You
actually,
don't.
I'm not very
No.
sure with the logarithm.
No. You have to do this. What we see is, if I say if I say 10 to the power 2 is 100. So my 10 is 2. My 10 is the base. 2 is the
Mm-hmm.
power exponent, and 100 is the answer.
Right.
Now the base never changes,
Okay.
and these two numbers will change their places.
Hmm.
The base will still be the same. The log of base is 10. Now instead of
Mm-hmm.
2, I will have 100. Log 100 base is
2. Okay.
2. Okay, instead of 10. 10 no, in other words, please look at this. 10 to the 2, 10 base to 2. So that is 100. You see?
Mm-hmm.
Okay? 10 base to 2 is 100. See? I'm not changing the base. Base is there. When I'm writing a logarithm form, base is still the same. Okay?
Uh-huh.
Instead of 2, I've got 100. Did you understand? If I
Yes,
say,
sir.
say
Mm-hmm.
2 raised to 4 equals 16. What I will say log to the base 2, log 16 to the base 2 is
Mm-hmm.
16.
Okay, okay, okay.
If I say no, when the base is, so usually the base is 10. If it is not specified, the base is 10. But okay, when the base is e, it's called natural logarithm. If I say e raised to 2 equals to how much, just check e raised to 2 is how much? The calculated e raised to
2.
at 7.389.
Uh-huh.
So it's 7.38.
So your log base e to the power 7.389 equals to 2.
So we will say log 7.38 to
Okay.
base e is 2. Now this is
Okay.
called ln. Okay? So ln 7.38.
Mm-hmm. Okay.
Okay. So now I am saying my ln t minus t is so much. Okay. Okay.
Mm-hmm.
Which means ln t minus t is the base e so much. So I can take the thing here. So therefore e raised to minus
Minus
kt
kt plus c.
is t minus t.
Mm-hmm. Right. Okay.
So this I've used the exponent rule. E raised to minus kt plus c is e raised to minus kt. It is e raised to c. This must be the exponent. Are you aware of this?
Mm-hmm.
Yes or no?
Yes, sir.
So e to the c is also some constant. C is a constant, e is a number. Constant. E to the c will be a number. Let's say lambda.
Uh-huh.
So t minus t is e to the minus t. Therefore, therefore, t is equal to t a a.
Mm-hmm.
Now, now it says that you just pour the cup of tea to the temperature of 75 degrees. Okay. So the initial
Mm-hmm.
temperature is 75 degrees and the room temperature is 24. So it is 75, 24, and time is zero. Initially, time is t equal to zero.
Right, right. Uh-huh.
So plus lambda is to zero. Right?
Hmm. Yes, sir.
At time t, when you pour the cup of coffee and then you started a stopwatch. So at t
Mm-hmm.
equal to zero, temperature was 75 degrees. Okay. So my lambda is how much? 75 minus 20.
Right. Minus 24. which is 24, 34, 44, 54, 64, 74. So 51. Hmm.
Your way is 24, which is at the end of the day 24. That's my equation.
Okay. That's my T. Okay.
I don't know the value of k. You have to find the value of k also. Okay. State the time at which the coffee cools most quickly. When will the coffee cool most quickly?
So I can't hear you actually very clearly.
When will the coffee cool most quickly? State
Sir,
the
I actually
time.
can't. Hello?
Yeah, go on. Go on.
Sir, I can't actually hear you very clearly.
Okay, the question here is, they asking you, state the time
Huh. Okay.
at which the coffee cools most quickly.
Huh.
How will you say this?
Can't go more quickly. So. Um. Um. Not sure, sir. Oh, what should I say here? Coffee cools most quickly.
Hmm.
So I mean at cool. So at lowest temperature. At lowest temperature then. So if you put temperatures as the lowest possible thing, then you find out time.
Most quickly, you know. Mm,
What do you think, sir?
the rate of cooling is proportional to the temperature difference.
Mm-hmm.
Now, the temperature difference is maximum at 75
Mm-hmm.
degrees Celsius.
Right.
So, therefore, it will cool most quickly at 75 degrees Celsius. Right?
Okay. Temperature is maximum at 75.
No, no, no,
Temperature
no,
is
no, no,
75
no, no,
degrees.
no,
Okay.
no, 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 my friend. It says that the rate of cooling, rate of change, is proportional to
Uh-huh.
the temperature difference. So dt by dt
Mm-hmm.
is proportional to temperature difference. So dt by dt will be maximum when this difference is maximum. Huh?
Mm-hmm.
K is constant.
Mm-hmm.
This difference will be maximum. No? I mean dt by dt
Mm-hmm.
will be maximum when the difference is maximum.
Right.
And difference is maximum at 75 degrees Celsius.
Okay. Okay.
Do you understand?
Huh, sir.
See, suppose I am saying rate of cooling dt by dt is proportional to temperature difference delta T.
Mm-hmm.
Delta T is T minus T.
Mm-hmm.
It means if delta T is more, dt by dt is more. Yes?
Mm-hmm.
Yes or no?
Yes, sir.
Now delta dt by dt
So when you say proportional, it means like say inversely or directly.
directly,
When
it
you
is
say
directly.
proportional, directly. Okay.
If it is inversely proportional, they would have mentioned
Okay. Okay.
dt by dt is maximum
When temperature difference is
when
maximum.
delta T is maximum.
Uh-huh.
Now delta T is maximum when at the start, when T is
Mm-hmm.
75,
Right.
delta T is T minus TA
Mm-hmm.
is T minus 24. So this will be maximum when T is 75 at the start. Later on it will cool. No? From 75 it will become 74, 73,
Mm-hmm. Correct,
70,
correct.
60,
Huh?
50. It's
Right.
maximum.
So
Correct.
we found the rate out, but they're saying find the time. Like we know the rate when it's max, but they're saying time, no?
Ah, no, not the time. They are saying where is it gone? Ah, state the time at which the coffee cools most quickly at
So
time
time.
t equal to 0 at the start. No?
So that's what I said, no, sir. At T, like, that's what I said, sir, first.
What did you say?
So I said when T is the lowest, which is zero.
Okay, now yes. Are you understanding? See, there's no working required. So are you understanding the logic?
I mean, I am saying, I mean, part A is just simple mind logic. I mean, when
Ah,
is
it is.
lowest, when
It
T
is.
is zero. So, what I also think, since room temperature is 24, how can the coffee temperature be at zero? Shouldn't that also be
No,
at
coffee is not
24?
zero. Again, you're mistaken. See, there are two T's here. Okay, let us say there's
Oh,
no,
say the time. No, it's fine. I got it, sir. Say the time, of course, huh?
there's a capital T, there's a small t. So at t equal to
Mm-hmm.
0.
Capital T is temperature, small t is time.
Now write the differential equation using the initial conditions given. Okay,
Mm-hmm.
see that they've already written.
Uh-huh.
Okay, so solve the differential equation, we've solved it. Hmm?
Ha ha
We've
ha.
solved it. Okay, now why explain from the equation why temperature will never go below 24 degrees Celsius.
Why, sir? I don't know. You can explain, sir, please.
Okay, see if temperature, suppose temperature is below 24.
Mm-hmm.
See my temperature is 24 plus lambda. Lambda was how much? 51. No? Okay, plus
Uh-huh.
51. Plus 51 e raised to minus kt. Hmm? Okay.
Yes, sir.
Now this temperature cannot go below 20. Suppose it goes below 27. Let
Mm-hmm.
us say, let us say T is 23.
Mm-hmm.
So it means 23 equals to 24 plus 51 e to the minus kt. Array
Mm-hmm.
again. Mm, oh no. Cheh, what is this?
So just try going back, no? No, sir. Okay.
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 Now,
Mm-hmm.
um, this means minus 1 is equal to e 51 e to minus lambda t. And
Mm-hmm.
minus, I am becoming now, it should be k, not minus lambda.
Mm-hmm.
Correct. No, it's minus kt.
Mm-hmm.
This means e to the minus kt is minus 1 upon 51. Hmm? Am I
Okay,
right?
okay. Uh-huh.
No, this is
I
wrong.
think so, huh?
This is wrong. No?
Okay.
Exponential function This is wrong because e to the power anything x cannot be negative.
Okay.
Correct?
I don't know. I think so.
It cannot be negative.
Okay.
Can you think of see e is what? E is a positive number. 2.7 is 2.718. Okay.
Mm-hmm.
Suppose 2.7. Now 2.7 raised to any number. Will it be negative?
No.
It cannot be. No? I say that 2.7 raised to any number. So I say 2.7 raised to minus 10, minus 1, or minus
Mm-hmm.
2. It will be positive.
Mm-hmm. Okay.
It cannot be negative.
Okay. Okay.
The exponential functions cannot be negative.
Okay, sir.
Okay,
Mm-hmm.
that way. So therefore, temperature cannot be less than 0, less than
Okay.
23.
Okay.
Also, from
Okay.
physics, you know that heat flows from higher temperature to lower temperature. Okay.
Okay.
So when the coffee and the room temperature are both at 24 degrees Celsius, there is
Mm-hmm.
no heat potential. So heat cannot flow because both the bodies are at the same temperature. Yes or no?
Yes, sir.
Okay, chalo, I think we can stop now. I think we
So
are doing
Oilers.
quite well. Huh?
Oilers.
Earlier, it's already 12 o'clock. Do next. We'll do it on Sunday.
So we
But we,
started also a bit late, 10 minutes late also now.
we
I mean,
did
if you say
start 10
it's
minutes
fine
late.
then, sir.
Huh? That's
Ah,
okay.
sir, we did now. But
Okay, chalo, Oilers number. No problem.
okay, sir, please. So because of this part, honestly, I found a bit complex. I have to practice. I'll see the recording after the class. Also, I'll have to practice more on this part. So
Uh,
let's do one more new concept then, sir, please.
okay.
Just
Okay.
a bit of introduction, maybe.
Why not? Why not?
Mm-hmm.
See, Oilers. Huh? Now, see, in Euler's method, Euler's method of solving differential equations.
Mm-hmm.
It's also called numerical method. Also called numerical method. Okay. Also
Mm-hmm.
called numerical method. Okay. Now, what is this? See, when you're solving a differential equation, what are you doing?
Mm-hmm.
Tell me. If I give you dy by dx.
I'm doing finding rate of change. If I'm doing for
No, no,
numerical
no,
things,
no,
or
no,
I'm
no,
finding
no,
gradient and
no,
slope.
no, my friend. Dy by dx is given to you. Okay.
Mm-hmm.
Suppose dy by dx is something. Suppose x.
Okay.
Now, what are you doing when you're solving this equation? Hmm?
I'm finding the rate of change
No, you're
of.
finding y.
Acha, acha, huh. I mean, if I'm being asked to find y, if I'm doing normal
If I
derivative
give
of
you,
something, obviously I'm finding rate of change.
no, you're not. You are given the rate of, you're not finding it. It is given to you. Okay. Rate of change is given to you. Okay.
Sure. Okay.
And you're
Mm-hmm.
finding y. Is that clear?
Mm-hmm.
Okay. So
Mm-hmm.
you have to find y. This is given to you.
Okay.
This is what. That is why, no, we found y. No, in this case, y
Mm-hmm.
was temperature. We found temperature.
Mm-hmm.
In the previous case, we found, where was that? That y square. This one. Okay. Again, we found y.
Mm-hmm.
Okay. So, so in the differential equation, we want to find y. Now, so far we have found y using integration. Okay. But suppose there is a function which you are not able to integrate.
Okay.
Maybe it is too complicated, whatever. See, because what
Mm-hmm.
we are doing textbook cases. When you're actually working in a laboratory, your y, your equation, your equation might be too complicated,
Mm-hmm.
and you cannot,
Mm-hmm.
you know, uh, you cannot find the equation by normal integration. So what do you do?
Mm-hmm.
We follow a numerical method developed by Euler.
Mm-hmm.
Okay, so y is how much? Okay, now see, uh, suppose I have got y equal to f of x.
Mm-hmm.
So dy by dx is equal to f dash x. Okay,
Mm-hmm.
which is suppose gx. Hmm?
Mm-hmm.
Correct? F dash x is gx.
GX, huh?
Uh, let me just say that for example, I will take example from here now. I should be break ahead. Uh, this one. Okay.
Mm-hmm.
We'll take an example. Uh,
So this whole concept is a completely different topic altogether, right?
what?
Euler's method.
It is Euler's method is a method for solving differential equation. Numerical method.
Okay.
We got this,
Okay.
no?
So
Here.
so 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 what I did just now, if you can't do it normally with integral, then you have to use Euler's method.
Okay. Right.
Okay.
Mm, okay, good. So we've got this.
Acha, so then I was thinking, so like I think, oh, instead of like going further with this today, I was just thinking, how about you give me like a video on Oilers maybe, then I can study Oilers before next class.
The video I'll give you. Why not?
No, that's what I'm saying. So instead of doing like
No,
instead
no,
of
no,
doing
no,
more on
no, no,
Oilers
no,
today,
no, no, my dear sir. We have 5 minutes remaining. I want to use those 5 minutes.
well, okay. I mean, you were saying that's what I'm saying, sir. I have no problem. Okay,
Okay. We will stick to 1.5 hours.
of course.
Yeah. Okay. This is it. Right? Now see, now look at this. What is given to you? Read
A
the question carefully.
differentiation.
Huh?
Y dash equals to 2y 1
What is
plus
y
x.
dash?
Y dash is the differentiation.
So dy by dx. Okay. So dy
Huh.
by dx uh, dy by dx is 2y, which is what I call gx. Okay.
Mm-hmm.
Now use Euler's method to find approximate values of y when x is equal to
Zero.
0.1, 0.2, and 0.3.
Okay.
Right. Now suppose, no, no, I will introduce the problem. Okay, we won't solve it now. Suppose this is my curve.
Mm-hmm.
Anything, okay, it could be anything. I'm just showing this. Now I'm starting from here. Suppose I draw a tangent.
Mm-hmm.
Yeah. Now, mm, suppose this is my point uh, x1,
Mm-hmm.
y1, point A. Point. I will write here. Okay.
Mm-hmm.
X1, y1. Now, at this point, at this point, this is my tangent. Dy by dx is the gradient.
Mm-hmm.
Okay.
Right.
Correct. My gradient is dy by dx. Now, so what I do is I will say okay. Okay. I will say okay. Now, this is my, yeah, that's better. Okay. Now what I will do is
Mm-hmm.
I know my dy by dx. That's the tangent. That's the gradient
Uh-huh.
of the tangent. Hmm. Now from x1 y1 I go to a point x2,
Mm-hmm.
point B. Now point B, as you can see, point B is not on the curve,
Right.
but I want a point on the curve. No,
Mm-hmm.
if I say my point B is here, okay. So the equation of point B, the coordinates are x2, y2.
Mm-hmm.
Okay, x2. However, I'm not getting by my point B is on the tangent. I don't know the curve. No?
Mm-hmm.
But if my step size is small, no? If points A and B are very close, then these two, this one and this y2 here, okay, these two will be the
Mm-hmm.
same. It means this difference will be very small.
Mm-hmm.
This difference
Mm-hmm.
will be very small, very small. Do you understand? Because
Yep.
if points A and B are very close, suppose point A is here, point B is here. Okay,
Mm-hmm.
so the difference is small. No?
Right, right.
I'm showing it here because I want to teach you.
Hmm.
Are you understanding?
Yes, sir.
Otherwise, this difference is small. No?
Correct, huh?
So the difference is my step size. No? The difference is small, then these two are the same. Okay. So now
Mm-hmm.
let us see. What is my gradient dy by dx? So y2 minus y1 upon x2 is
So,
dy by dx.
mm-hmm.
Okay. Okay. So
Yep, yep.
y2 is y1 is x2 minus x1 into dy by dx.
Uh-huh.
Yeah. So therefore y2 is y1 plus,
X1 dx.
correct. Now this is my
Mm-hmm.
Euler's method. Okay. Now what does it mean? Now this will see my step size. should be very small. So my x1, x2 minus x1 should be small. Step
Mm-hmm.
size is this. See, my step size now, you will have to understand. This is my step size. X1, y1 is here. Okay.
Mm-hmm.
This is my step size with h. Yeah.
Right.
This should x2 minus x1 is the step size. Hmm? If this is small, then this point and this point will be almost the same. Okay. So
Okay.
now, which means
Okay.
now my y two is y1. Okay. Now see, I know that y is 3 when x is 0.
Mm-hmm.
So when x is 0, y is 3. So my first, I start from here. So my first
Mm-hmm.
coordinates x1, y1 are x1, y1 are 0, comma 3. Okay, when
Mm-hmm.
x1 is 0, y is 3. Okay, now I want to
Uh-huh.
find y2. Now my x2 will be, see, x2 minus x1 is 0.1.
Uh-huh.
So x2 is x1 plus 0.1. x1 is 0.
Uh-huh. Mm-hmm.
0 plus 0.1 is 0.1. So my x2 is 0.1. Do you understand?
Yep,
Step
yep.
size. Okay? So now, what is my y2? My y2 will be y1 plus 0.1 into dy by dx. Now that is 3 plus 0.1 and dy by dx is how much? 2 into y plus
Uh-huh.
2y.
Plus x. 2 into y, 1 plus x. Huh. Plus x.
Now which is,
Mm-hmm.
now we are finding y2. So this will be y1 and x1. Okay. So
Mm-hmm.
3 plus 0.1 into 2 into 3 into 1 plus 0.
Mm-hmm.
So 6.6. So 3.6. So my y2 is 3.6.
Okay.
So my second point is x2 equal to 0.1, y2 equal to 3.6.
3.6.
That is my x2, y2.
Okay.
Now I'll have to find x3, y3.
Mm-hmm.
Okay, now what will be x3? x3 minus x2 is 0.1.
Mm-hmm.
So x3 is 0.2.
Correct, huh?
Now can you find y3? So y3 will be y2 plus 0.1 into 2y y2 into 1 plus x2. And dy by dx is this, no?
Mm-hmm.
So y2 was 3.6 plus 0.1. Now y2 is 3.6, no?
Mm-hmm.
So 3.6 into 1 plus 0.1.
0.1, yep.
Hmm. Correct.
Huh.
What will that be?
Um, that'll be 3.6 plus. I mean, so I can't see what to find because I'm moving the thing. Huh.
Moving.
Plus 3.6 plus 0.1 into.
7.2.72. So 0.72 into 1.1 is how much? 0.79?
So
3.6
just
plus
one
7.
second, sir. Just one second. Point 6 1 plus 0.1. So 4.39.
Okay, that's it.
Yep.
Okay, now you
Okay.
can find for other values you can find.
Yeah, so,
Okay.
so just one last question. So for every time where they have to use Euler's method, they'll say it, right? They use
Ah,
Euler's method.
they mentioned.
Okay.
Look,
Uh,
look, see, do you
uh,
see this? Consider the following differential equation. Use
They
Euler's
have mentioned. I was asking
factorization.
will everyone mention or not.
They have to mention, they have to give you step size,
Acha, okay, okay.
all that they have to do. No?
Done, sir.
Okay,
So
chalo.
basically, sir. So basically, sir, this was honestly a bit complex. I'll have a look at the recording also once, and if I have any doubts, I'll get back to you, sir.
Hmm.
Done, sir.
Okay, chalo. Bye
Okay then,
bye.
sir. Thank you so much, sir, and good night. Okay, take care, sir. Bye.